So, good evening, everyone. It's a pleasure to welcome you all to today's meetup session, Streamlining Machine Learning Pipelines Using Vertex AI. This event is hosted by Data Couch, and we are honored to have Mr. Shadab Hussain as our speaker for the session. So,
Thanks.
Shadab Hussain is a distinguished leader in Gen AI and quantum computing, currently working as a senior associate at MathCo. He co-founded Quantum Computing India and has an extensive background in AI, engineering, and quantum. Shadab previously worked as a developer advocate at the London Stock Exchange Group, a published researcher and co-author of a quantum computing book in finance. He contributes to Google developer groups and AWS community and speaks at key events like Data Engineering Summit, Quantum Innovation Summit, and Quantum Tech. We warmly welcome Shadab and look forward to his insights during today's session.
Thanks for the intro.
Yeah. So now let me take a yeah, Shadab, you wanted to add something to that?
No, just please continue.
Okay. Now, let me take a moment to introduce you all to our organization, Data Couch. We are a professional service delivery company that specializes in generative AI, data, cloud, agile, DevOps, data science based consulting, implementation, and training. In addition to our core offerings, we provide browser based lab solutions and managed services. We are leaders in bleeding edge technologies like generative AI, blockchain, NFTs, streaming analytics, AR, VR, cybersecurity, drones, and many more. We are pleased to announce that we have a global presence and have transformed over 150K professionals through various technologies, primarily focusing on Web3, generative AI, big data, DevOps, and cloud. Highlighting our impactful footprints, we've successfully collaborated with Fortune 500 organizations and GSIs like Infosys, Accenture, and TCS. We believe in sharing knowledge with the community and have created 3 meetup groups, that is AI Minds, Generative AI User Group, and All Things Data. Our community is over 121K strong, and so far we have conducted over 200 plus meetup sessions covering more than 100 plus technologies. Our recent achievements include being recognized by Confluent as a global education partner for the second year in a row. And we are the first training delivery partner for Starburst and OneHouse. This was a short introduction about our organization. Now, I would like to invite Shadab to take over.
Thanks, Siddhant, for the intro and for the invite. Let me share my screen.
Yeah.
I hope it's visible, right?
Yeah, Shadab, your screen's ready.
Right. Cool. I hope slide is also visible now.
Yes, they're visible.
Perfect. So, good evening, everyone. Good evening and good morning. Okay. So I'm Shadab, and thanks, Siddhant, for the intro you have already given, so I don't have to spend much time on it. I will start with the slides. So today's agenda will be like, we'll understand first MLOps process, why it is important, what are the hidden technical depths whenever we work on any of the data science or machine learning use cases. And after that, we'll look at principles of MLOps lifecycle, what are the different maturity levels which organization achieves when working on the projects, and where the existing technology landscape lies. So after the MLOps introduction and understanding, then we will dive to the Vertex AI platform, which is developed by Google, which handles end-to-end MLOps process. So starting with this, as a ML engineer or data scientist, whenever we work, right, there's a whole process which we need to go through, or which we follow, and there are different steps which we need to go through. For example, starting with the data itself, right? uh, Data lies at different sources, and it will not be very in clean format or ready to use format, right? We have to explore the data, we need to validate it, then we need to clean it. And after that, once we clean that data and data, we like find that data is ready to be used for the use cases whatever we are trying to solve using like machine learning or for our analytics use cases. Then like further we like store that golden layer of the data somewhere and we use it. So let's assume if this is that golden layer of the data, and we have the machine learning use case which we have to work on. Further steps will be to split that data into train test. Then the model engineering will come in picture, where we experiment with a lot of different machine learning algorithms to get the better efficiency out of that model, right? So we'll have code, we'll play around the parameter, we'll tweak the code. And then while doing all this, we perform certain feature engineering as well to get better results. And obviously hyperparameter tuning and all are optional, but for certain use cases we go with that as well, right? And after training the model also, our struggle doesn't just stop over here. Let's assume we trained the model, we got 80 to 90% of the accuracy with one of the model. But it's still at the model evaluation stage, we need to like go through all the models, whatever we have come across, and we have to select the best model out of it. And the combination of the metrics, like let's assume if it's a classification use case, then we have to look for what's the accuracy of my model, precision, recall. And this metrics again depends upon the use cases. Like for all the use cases, accuracy cannot be the right metrics to look at. So this is just till the model evaluation phase. And once we overcome that and we have to like deploy that model, or we have to make sure that we are able to make use of that model, we have to package that model and deploy that at somewhere. And given we have different libraries also, like we have TensorFlow library, PyTorch library, scikit-learn and all. So the model output which we get, or the model format, the output of the model format is like it's not very unified, right? Then we have to package that model in a simple format like 1x or jar or .pickle, so that it is a unified approach for packaging the model and deploying that wherever we want. So there are different type of use cases which we work with, right? Like it can be a batch processing use case, or it can be online serving use case as well. So in case of online serving, the model gets deployed at some endpoint, and we have to serve that model using some API endpoints. And there are different ways of deploying that model. We will not deep dive much over there, but this is the overall process still: model training, cleaning the data, and deploying that model as well. So while experimenting all this, while performing all these things, right? Many times, like as a data scientist or as a ML engineer, we get lost in all these experiments whatever we are performing. For example, how to keep the track of what data did I use for a particular version of the model, or what was the combination of the data, model, parameters, and all, which gave me, let's say, 85% of the accuracy with that experiment. So while working on the use cases, it's very obvious that we get lost in our own experiments, and it becomes difficult for us to track what data version, what model version, which model, what combination, and every other thing, right? So, and earlier people at the very initial stage, like if I go back 5 or 6 years back, how people used to work was like they used to maintain some Excel sheet and all. And obviously, like the Jupyter notebook was the go-to tool for the data scientist. Still it is, where they were writing their code, they were performing the experiment, and they were maintaining an Excel sheet. And it was taking a lot of time, and the experiment was also not easy to be shared by the other co-workers, other data scientists. Uh, that was the normal problem. And after that, the model has been deployed also. The problem is how to make sure that whatever model we have trained and deployed, it is performing well as we want, and it's not getting decayed over the period of time, right? So model monitoring and logging is also one of the like steps of the end-to-end machine learning process. So if you look at the whole process, right, like earlier when people started with data scientists or ML engineering, it was sort of traditional machine learning just. But as the industry keeps getting matured, we realize that software practices are also should also be the part of this, and we started adapting certain things from the software code pipeline, like how the code can be promoted, how we can version the code, version the data, version the model. All these practices we started adapting from there. So, like to summarize all this, right? So, ML code is just one part of your end-to-end machine learning use case, whatever you're working or building on. But there's a whole lot of things which people, as a data scientist, we ignore certain times, or we are not very much sure how to track that, how to manage that efficiently. For example, the configuration for your code or for your infra and all, we will have different configuration files, how we are collecting the data, validating the data, right? What are the analysis tools we are making use of, how we are extracting the feature, what are the project management tools, how we are monitoring our pipeline or the infra, what is the infrastructure which is used for serving the model or even for training the model, right? And how we are managing the resources and all, like whatever is getting used over here. So ML code is just a very small piece of your end-to-end ML project, but there's a whole lot of other things which goes in the picture. So that's why MLOps came in the practice. So it is a like to understand MLOps, right? It is a set of tools, practice, and techniques, and it's not just like me or the job of MLOps engineer to make sure that everything is up to the standard of how it needs to be, but it is a culture and mindset which organizations have already adapted or started adapting to make sure that the deployment process can be faster, or the productivity of their ML engineers or data scientists can be at peak. And all another benefit of that is like it reduces risk and cost as well. Like earlier, if you have to do everything manually and all, it takes a lot of time. We are not able to monitor the infra and all, right? So that ends up taking up a lot of time from the data scientists and ML engineers as well, and the time to deploy was also very high. But with the MLOps, as this practice started getting adapted by the people in the industry, the deployment time got improved a lot. We were able to monitor the model and infra both. If model is getting decayed or if there's any drift in the data because of which the model performance is going down, we were able to monitor it and take the action at the right time. So what is MLOps, right? So MLOps is a combination of ML plus dev plus ops. That is like we have machine learning code, then we have the development process, then we have the ops process. So the combination of all the three steps is called as MLOps. So at the machine learning step, what we do is we experiment with the data and the model, right? We have the data acquisition, and people working at this layer are like machine learning engineers or data scientists, and they have the good understanding of business, and based on that domain understanding, they build initial models and all. So that is sort of experimentation phase, coming up with the right set of the models, coming up with the right set of the features from the data and all. Next step is development process, right? Where whatever model has been developed by the machine learning engineer or data scientist, we package that code, and we make sure that proper testing process is in place. We have proper CI/CD pipeline in place so that the code shipping or release of the new code or changes is faster and easier for everyone in the team. And next part is the ops part, where we make sure that continuous delivery is happening, and we have the feedback loop also for the data, and we have the monitoring also established for system and the model. System means infra, and model means whatever machine learning model we have built and deployed. We are continuously monitoring it and taking the feedback. If any anomalies we observe, if any changes or any drift we observe, based on that, the alert will be triggered, and the corresponding stakeholders will be notified for that. Right. So if you look at this, right, so as the data comes from the raw sources, we have the data ops part, will not die. Like each of these sub nodes itself are a very huge topic to go in depth, but I'm just giving you the glimpse of like what all comes in end-to-end ML pipeline. So data ops itself, like we will have a CI/CD pipeline for that, and data engineer will be mainly who will be working on this. And based on the requirement gathered from the business stakeholders and the data scientists and all, they will be building the data pipeline. The output of that can be the feature store or the silver or gold layer of the data over here. Now that data gets consumed by the like at the experimentation stage also, the data scientist or ML engineer can consume the data from here. The DE pipeline can be separately out of this process, or at in certain use cases, if it is end to end, then everything will be automated and connected one by one in the production. Or if CI/CD pipeline is in place, where we'll have the MLOps platform for the CI/CD as well, where we will read the data from this feature store source. We'll have the code of the data scientist, and we will be training the model, validating that, and then we will be saving that model output to the model repo by like putting it proper version and serving and monitoring it. So this is your end-to-end life cycle sort of thing. Okay, and I will be monitoring the chat as well. So if you have any questions, please keep sharing that in the chat. I will take up as and when I can take it. Yes, Tushar.
There's already a question there.
Yeah, so yeah, thanks for informing. So yeah, Tushar, DevOps part is almost similar, but there is bit of changes here and there. So DevOps remains the same, but there's additional component which comes in the picture of how what else we need to leverage in the ops process for the machine learning. That's a bit different. For example, in software engineering, we don't have models, so we don't have to version the models, and we will not have any model repository and so on. So coming to the MLOps principles, right? So these are like roughly I've tried mentioning whatever we can in terms of different principles of the MLOps. So first is versioning, right? So whatever we have, whatever artifacts, models, data we have, we need to version that so that at the moment, if we have to go back or track any of the experiments, it is the reproducibility or changes whatever we are making becomes easier to track. So that's why the data pipeline gets versioned over here. Feature is true whenever the like new uh, data is coming from the data pipeline. That also get versioned, right? Model objects, whatever the model output, model object is coming after training the model, that get versioned. Model hyperparameters, which set of hyperparameter correspond to which version of the model and all. That's why the versioning is important for this. Experiment tracking. Experiment tracking, there are certain tools. I don't know how many of you have used or heard of ML, weight and bias, these kind of. But these tools are used for experiment tracking, where for each of the experiment you're performing, you can log all the model details, like its parameters, its metric, which algorithm you have used, the data version which was used while performing that experiment, and so on, right? And code versioning is the normal practice which we adapt from the software engineering. And for that, we make use of like GitHub or any Git-based tools. Then we have configurations as well, which needs to be versioned, because as the changes keeps happening, right, it's not necessary that configuration whatever we have put in place at the initial stage will remain the same. Those are also like bound to change. So versioning is one thing. Then reproducibility. So what do we get by versioning, right? Let's assume if we have built and deployed a model at the I mean, right now, and we have to sort of after 2 months or 3 months, we are observing that something we have missed out or some anomalies have been detected, and we need to go back and reproduce the results or reproduce the error whatever we have encountered, right? So in that case, reproducibility plays a very important role. You don't have to like juggle around in understanding or doing everything manually. Since all the things have been versioned, using the version and finding out the right combination of the versions, you can reproduce any of the experiments or any of the pipelines which has been run in the past. So data versioning, versioning of feature engineering, hyperparameter, like the combination of ML models is same or not, right? Results in reproducing the pipeline output. Then testing also plays a very important role over here, because we can't just go with whatever the output we get from the data pipeline or from the ML and ML pipeline and all, right? So we need to validate the data. We need to make sure that whatever process we are following for the feature creation is in alignment or not. The integration of the data pipeline or with the ML pipeline is proper or not. Whether the ML model, what was getting produced from the training pipeline, is relevant and giving us the enough efficient metrics to go for the deployment on. So those part will be the part of the testing process. Then deployment, like earlier when we didn't had any proper like DevOps process in place, or we were not having proper versioning and serving process, right? It was a bit difficult, like how to deploy the model and all. And there were certain stats like 70 to 80% of the model they get trained and experimented around, but they never make to the production, right? But with MLOps process and all, the deployment process also like got faster, and we can rely on this. Then we achieved end-to-end automation. So there are different stages of MLOps maturity level, which we'll get to, like what level of automation has been achieved, can be achieved at what maturity level. But just to understand the whole pipeline, be it any of the steps, right, in the ML pipeline end-to-end, data transformation, your feature engineering, model training, or deployment, or application building and deployment can be sort of like automated. And very important phase is like monitoring. So earlier people were not monitoring, they were just training and deploying the changes or the pipeline or the models. But with the MLOps like process in place, we started monitoring our data. We started monitoring the quality of the data. We started looking at whether the data for our use case is getting drifted or not. Because if you just take the example of like pre-COVID market and during the COVID market and post-COVID market, right? The consumer behavior, for example, if we try to understand, there has been whole shift in the consumer behaviors or the user behavior, be it for online shopping or your in terms of browsing the internet or your or visiting to the places and all. So if you go with the same model which you trained before COVID, that will not perform well during the COVID phase, right? Or post-pandemic phase. So that's why this is a very simple example I've taken. So that's why the monitoring is very important, as and when the data or the behavior, so behavior we observe from the data itself, right? So at the end, if the data is changing, it will impact your model output as well. So that's how the model keeps started getting decayed. So how to make sure that the model performance is up to the par, like whatever we are expecting. And if any changes or any drift we observe, there will be alert mechanism and all, which can help us in retrain the model and go with the newer version. Okay, so to understand end-to-end MLOps lifecycle, we start with the data model and management. Then we develop the model, we train it. Then there will be a continuous training process in place. Then we deploy that model. After deployment, it will be like continuously serving in case of online use cases, like it will be API endpoint or it will be batch processing endpoint. And then we will be continuously monitoring this. So this is your end-to-end like MLOps lifecycle. This is the another version of that. Like if you look at, we start with data gathering, telemetry and logging. Then we ingest that data, clean and transform that data and do the feature engineering once that is done. So this is the data pipeline which keeps getting refreshed with whatever cadence we choose for training, for getting the newer data. And each use case will have their own cadence to get the latest data. Then we do the feature engineering and train. So this is like something which we keep improving over the period of time. Let's assume whatever the initial set of features we have decided to go with to train the model. Later on, during my experimentation, I can found like this can be improved even further by creating these new features or by excluding these features. So whatever feature selection process we have in place with the help of that, right? So feature engineering and training is one thing, and after that, whatever experiments we perform, we deploy that online or offline. So there are certain key benefits of MLOps. Just to reiterate whatever we have covered so far. So MLOps like results in shorter development cycles and shorter time to market. We don't have to wait too long, or we have to go through all the technical complexities if we have the proper MLOps process in place. The team members can collaborate better, be data engineer, ML engineer, or data scientist. The end-to-end flow will be very much optimized, and the team members can use their time much better and efficiently, focusing on the right things rather than focusing on something which is consuming a lot of time. The reliability, performance, and scalability gets improved for the end-to-end ML systems and even the security perspective. So I don't know how many of you are aware of MLSecOps, which deal with the security perspective of the machine learning uh, models or systems. There's a whole organization which is working on it, and they keep doing certain podcasts. So if you're interested, just check it out. But yeah, MLSecOps is also one of the important aspects of the ML systems. Then we have streamlined like operation and governance process. So compliance and governance is also something which needs to be looked at. Uh, and at the end, it results in increased ROI on the project. So like obviously, the more and more projects will be making to the production, and use cases will be very much optimized and reliable to like make the changes or to deploy that in the production. So, talking about the technical capabilities, right? So, if you look at like how your layer by layer it looks like. So, very first, obviously, we'll have the infra, right? So, whatever cloud you're working on, or whatever on-premise, if you have the whole model training and serving capabilities. So, like the different type of cloud models, right? On-premise, hybrid, or just cloud. So whatever infra you choose, there will be a security and privacy layer over there, which makes sure that everything is governed and in compliant with the company policy, or if you're working in a service-based industry with the client's policies. And then we will have source and artifact repository for our CI/CD pipeline, and whatever machine learning metadata or artifacts get produced from the pipeline. Pipeline means any of these steps. So this is my end-to-end pipeline, right? That will be getting logged at this stage. And obviously we have data set and feature repository, which will be like helping us in getting the data from over here. So in between, we have all the steps which we perform in end-to-end ML projects like experimentation, processing, training, evaluation, serving, online experimentation, monitoring. Then it comes the pipeline. And after that, we have the model registry where we register the model and it serves further. Right. So these are the technical capabilities. Like for everything, whatever we discussed so far, right, can be managed end to end on the Vertex AI platform. We will look at how it can be managed, but for now, you just understand this part. Vertex AI is a platform, and this is a very high level architecture. I've just pegged it from the internet to give you the feel of like how the flow look like when you build something on cloud. So you can see it starts with data engineering, then we have feature engineering. At feature engineering step, we have feature restore, right? Then we have model training and calibration, evaluation, production, and deployment. And for each of these steps, certain things can be directly handled with the features available on Vertex AI. And for a few of the stuff, we need to make use of other services available on the cloud. Okay, and it's not like very hard and fast. You have to go with that service as well. Obviously, there are certain alternatives as well for the tools. But if you just stick with the Google Cloud, then we'll look at like how it can be used. Right. So Vertex AI had the feature store capability as well, and whatever metadata gets produced for whenever you perform in experimentation or whenever your pipeline runs, right, it gets logged in the Vertex AI metadata registry. So there you can go and look your metadata for each of your pipeline runs. Then we have Vertex AI managed pipelines as well. So the whole pipeline for each of the steps can be built, and you can that will look like a DAG where you can see and monitor your pipeline run. If any of the steps fail, you can check the logs and see why it has exactly failed. Okay, so can I get the viewable link of the PPT? Sure, Tushar will share by the end of the session. Okay. So this is high level architecture of the like Vertex AI, like how it will look like on Google Cloud. Before like last 15 to 20 minutes, we'll just look at the hands-on and the Q&A. But before that, just try to understand like what are the different maturity level which an organization try to achieve And it's not needed that you should be at the level 4. If it is at level 4, it is very well and good. But it is not recommended also to be there, because if you don't trust your pipeline models data end to end completely, don't go for fully automated. Because this might can cause some issues in production, rather go for level 3. And so based on different projects and all, when people were working and no MLOps were in process, everything was like manual. Like whatever ways of working I've mentioned over here for data scientists, data engineer, or software engineering teams. Then when DevOps got combined with the data science or machine learning process, right, we started automating certain steps like data pipeline, like how we can extract the data automatically, end-to-end data pipeline, how it can be built, right? Testing for the data pipeline build and versioning. So a certain sort of automation was achieved, but it was not like still very efficient to increase the productivity or reliability on the pipelines. Then it was level 2 where we see load means like people were working individually and they were just handing over the code or whatever the findings they have. Then the next team member has to work, restructure, and build the pipeline or deploy the code and so on. Then we have some coordination with teams where we have automated model orchestration and all. So this is this maturity level where data scientist, data engineer, or ML engineer, they coordinate a bit with one another, and based on that, they structure or they take accountability of the other process as well. And based on that, they write their code or version their code and so on. So at this step, we were like, along with whatever we achieved in like DevOps with MLOps step, we had a proper experiment tracking in place where data scientists can collaborate with one another and can share the experiment, automated model scoring and versioning. So this also came in the picture, then managed model compute and all. Then we have direct collaboration across teams. At this stage, we were able to achieve like automated model deployment as well. So we had the CI/CD in place, we had the feature store in place, model monitoring. Feature store is still optional for many of the organization. It's not needed that all the organizations will be implementing feature store. And certain components of the MLOps depends upon the like organization's aspiration as well, what all they want to keep or what all they want to adapt. But at high level, if I have to talk about, then all these things were like sort of automated model monitoring, experiment tracking, versioning, and so on. Fully like level 4, like this is the highest level of maturity for MLOps. And here, along with whatever CI/CD, model monitoring, and all we have in place, the model retraining also gets triggered automatically based on the certain metrics which will be capturing and monitoring for data drift and model monitoring, right? So based on that, if we will be obviously setting certain threshold, like if my drift is, let's say, more than 0.5%, then my model should be trained automatically. So in that case, the automatic retrigger will work. So this is sort of like MLOps maturity level. Before I move ahead, any questions from anyone? Is it too much of information? I mean, for those, it is like coming across all this for the first time, yes. But just try to grasp whatever you can. Ashraf, what's the question? What are the retraining triggers, right? So retraining triggers are sort of the logic implemented in the pipeline. Let's assume if we observe, I was saying drift, right? Let's say if we observe data drift more than 0.5%, whatever we have configured. So in that case, based on the logic, the model training pipeline will be automatically re-triggered to train the new model. Smita, LLM ops itself is a whole different process and concept. LLM ops are for large language models, and this we are talking about machine learning models. Certain aspects will be overlapping when we look at MLOps and LLM ops, but not everything. Because the infra performance and scalability and retraining and all, fine tuning and all is different. Like that comes in LLM ops, and for MLOps, it will be different. Are there security and quality gates also being trained for new models? What do you mean by security and quality gates, RK? like quality, I can like understand. You mean the model performance, efficiency, and on these lines, right? So yes, so based on whatever drift we observe, if the performance itself is decaying, that means the efficiency is going down of the model, right? So that's the gatekeeping for that. Like if the performance is going down, either you can just inform the corresponding stakeholders through the alert mechanism, or if you are at the level 4 of fully MLOps automated training, then it will like re-trigger the model training pipeline. In terms of security, security is a practice which is taken in accountability end to end, not just at a particular model layer or somewhere. Uh, to make sure that there's no data breach, there's no biasness, like there's no infra breach, whatever we have to take care of while training these pipelines. The size of the data, it depends how soon you know the drift retraining frequency. So there's no uh, threshold in terms of time, Ashraf, like how soon we'll get to know. It completely depends upon. So data suddenly doesn't change, right? It changes over a period of time. So when you will be monitoring your data and model, you will keep looking at those changes a bit over a period of time as it is. And you have, as a data scientist, we need to take the call on what's the allowed threshold we can go for these changes. So as you see your threshold is getting crossed, you have to take accountability of like relooking at your model. Retraining frequency, and also retraining frequency depends upon your use case as well. For example, for certain use cases, the model gets trained bi-week, like bi-monthly, monthly, half yearly, and so on. But based on the performance of the model, if retraining frequency needs to be established, then that will be based on the drift metrics or model metrics, whatever we'll be monitoring. And then if it goes beyond that certain threshold, then we need to retrain the model. Scalability depends upon our use cases, Ashraf. For example, if it's an online use cases, so the model has been deployed at a certain endpoint, then in that case, your let's whether you're using Docker-based deployment or Kubernetes-based deployment, the infra deployment should be taken care of properly so that if you need to upscale or downscale the infra, the scalability is getting taken care of automatically. How we quantity the quality of the model. So those are based on the metrics, right? Like whatever model you are training. For example, if you're training some classification model, then in that case, you will have classification metrics like precision, recall, F1 score, accuracy, and so on, right? So based on that, you have to like decide what's the quality of your model. Cool. Any other questions before I move ahead? All right. Keep posting the questions in the chat, whatever doubts you have, so that we can clarify in the chat itself. I will move ahead with the next slides for now. So tools, I'm coming next now, Rahul, for that, like for the next question. So this is the technology landscape where we lie, right? So for machine learning, you can see all these libraries we have, like most commonly used one is like scikit-learn, TensorFlow, PyTorch, XGBoost library, and all. Okay. Then for deep learning, sorry, for machine learning, we have scikit-learn and H2.ai. These are certain of the tools like if we talk about library, then we have scikit-learn and XGBoost, light GPM libraries and all. We have different frameworks as well, like MLNet and all. And then we have different platforms for machine learning like Kubeflow, H2O, MLflow, and so on. Seldon Core will be different. Then for deep learning also, we have different frameworks, platforms, libraries for reinforcement learning. For programming, we have languages like Python, Julia, so on, right? Then for notebook environment, we have Colab, Jupyter Notebook, Jupyter Lab, and certain online hosted platforms also we see. Then for data, we are versioning. The most common used tool is DVC. I don't know how many of you have used DVC. If you have not used after the session, try go and check out these tools. Then we have different storing and for storing and formatting, like we have different tools like Milvus and Delta Lake, yes, and what else, Vespa, and so on, right? And for operations, we have like Feast. ops works and all. Then for feature engineering, we have TS Fresh and all. So it's not like needed. You have to use all the tools and everything. It depends upon your use case, what exactly makes sense for your project, and what kind of automation and maturity you want to achieve. Based on that, like select the right combination of the tools and go with. So uh, model explainability, checking for the adversarial attacks and all, right? Biasness and fairness is also very important. So for that also we have certain tools available online. And for explainability, one of the commonly used tools packages like SHAP, Lime, these one. Then for model training, benchmarking, or putting up a workflow for inferencing and all, we have different tools for that. And then for distributed computing, we have like different platforms again, like Kubernetes based. You can like most commonly like people what they use is Kubernetes based distributed computing, where we have different pods or nodes where people can train their model and distribute the load. Then for security and privacy, there are each of the online cloud platform, they have their own services. Then this is for NLP education and all. So this is like high level technology landscape, and this doesn't cover all the tools whatever we have in the market. This is just to give you the glimpse of like what all tools we can have and can make use of. Okay. So coming back to the Vertex AI platform, so Vertex AI, like whatever we talked about so far, it has auto ML capability as well. It can train the model without any code with minimal expertise required. And we have a very unified UI for the whole ML workflow. And we can manage the model. We can look at the version of the models and everything. And we have pre-trained APIs as well for natural language, for vision, for video, and even for if you're working on any of the GenAI use case, then that also you can sort of leverage. Okay, so excited to go for the platform demo and hands-on. Yes, no, guys. So I will be demoing very basic example. Okay, like it's not very advanced or too techy sort of thing, considering it's a mix of audience. Okay, so certain things I need to replace over here. Just give me some time. Okay, so this is the wine use case, which here we'll be just focusing on how the pipeline can be built, how the components can be built, and how when you execute the pipeline, how it looks like. And after covering the pipeline part, we will look at how end-to-end CI/CD pipeline can also be incorporated using the Google Cloud Services, sort of. Okay, so first, before starting, understand the Vertex AI platform. So Vertex AI platform is the earlier it was known as AI platform, which was developed by Google to work on AI use cases. Then later they renamed it to Vertex AI, and 2 years or 1 year back, it didn't had these many features what it has right now. Okay, and now if you see, it has a whole lot of features, and certain things has been removed also as part of the revamping or restructuring this platform. So in this platform, if you look at the list of the APIs, right? So like very first prerequisite is like whatever APIs you're going to make use of, make sure that those are enabled on the platform. So here, if you look at Vertex AI API, Cloud Storage, Notebooks AI, Notebooks API, Dataflow API, and there are many other APIs like artifact registry, data lineage, data catalog, compute, vision, and so on. So if you're working on traditional ML use cases, then these or deep learning use cases, these are good enough to start with. If you have some generative AI use cases and all, then they are extra prerequisite for that, which you need to take care of. Okay. So here, if you look at the dashboard itself, right, you can make use of, so Google also provides Collab, right? And it has free version and enterprise version. If you want to play around within the Collab, then you can leverage it from here. You have Model Garden. Model Garden is the sort of list of all the models, whatever we have online provided by Google. And it is not just Google created models, but also models from different other companies or platforms or services as well. Okay, so for example, Llama 3.1 was being released recently, like a few days back. So whatever model you want to experiment around or play around, you can leverage that, and they have very nice UI to play around, and you'll be able to build and prototype your like use cases and even take that to the production, like however you mature. So Model Garden is the is the like marketplace for all your models. Then we have Vertex AI Studio. So this is where like you play around with your like LLM or generative models, and you play with the you play even with this what do we call AI prompt playground and all. So for example, if you have some use cases where you have to fine tune the model and all, that you can do over here. For preparing data and all, you have different set of services like data sets, labeling, and visual store. So all this can be utilized from here. For the model development stage, you have Model Garden, obviously, where you can pick the model, fine tune the model, and so on. If you are working on traditional machine learning use case, you can train the model in Vertex AI, and your experiments can be logged under the experiment tab. And whatever experiments you're like is getting logged from your pipeline runs can be tracked, visualized, and can be compared. Then we have metadata for each of your pipeline runs, which will go in this like here. If you see metadata experiments and training, we'll look at the UI of each of these. So this is where you will see the like component or like features related to the model deployment, model development, sorry. And then we have deploy and use. For deploy and use, like whenever you train a model, if it meets your criteria and threshold, then it gets registered to the model with a particular version. So model registry will be the feature for your for managing your model. Then if it is an online, like if the model needs to serve online, then you can make use of online prediction. If it is a batch prediction use case, like batch processing use case, then you can go with this. And then we have vector search that gets used for this DB gets used for the LLM use cases. So this is high level understanding of the platform. So for traditional ML use cases, what do you use is mainly you should be aware of how to build the pipelines and all, right? And the data scientist or ML engineer needs a platform to work on it. So this is the workbench. It is like it is if you create a new workbench, it is very simple to do that. Just click on create new, give some name, select the configuration and the region, whatever you want. If you need TPUs and all, you can select that as well. And based on the configuration, like if you want to go with certain advanced configuration, you can come to this page, click on continue, whatever configuration you want to provide from here, whatever compute type you want to perform based on your use case, you can select that compute type, and your workbench will be created with that configuration where data scientists can play around and experiment. Okay, so for now, I already have a workbench created with the name data couch. So if you open that, it will take you to the environment like this. This is a online compute hosted Jupyter Lab environment where you can connect with your Git repository. You can like check in, check out your code from here itself. If multiple people are using the same workbench, they can see all their they can see one another codes as well over here. So for example, there's a whole repository being curated by Google itself, where if you want to look at different use cases, samples, be it related to traditional machine learning use cases, Kubeflow, pipeline, whatever you want to explore and look at. So they have certain official notebooks, and there's certain notebooks which have been contributed by the community, user like me, you, and everyone else. So those contents will be available in this. So you can just go over here, copy the cloning link, and come to the workbench here. Click on Git, clone a repository, paste the URL, and your repository will be cloned on this workbench. Before I move ahead, any questions from anyone? We have just 10 minutes left. So if you have anything, just ask me or I will keep going. All right. So if you look at this, right, so my repository has been cloned, and whatever notebooks and content I have, I got access to everything over here. Okay, so if you want to look at any of the use cases, how to train the model, how to deploy the model, how to create, like this is the basic use case again. So just one more thing for your knowledge, Vertex AI pipeline or what Vertex AI, not everything on Vertex AI, but especially the pipeline component has been built on top of the Kubeflow. Okay, so Kubeflow is a open source project which is built and on top of like Kubernetes. Okay, and Vertex AI is has been built on top of Kubeflow. Like it has abstracted a lot of more complexities and improvised that platform. So if you understand Kubeflow, you can like work with Vertex AI very easily. So just check out this documentation, understand how the pipelines and components work over here. And if you want to host your own Vertex AI or Kubeflow-like environment, you can deploy and you can run Kubeflow on any of the platform, be it AWS or Azure. And on if you want to host your own Kubeflow like services and control everything manually, it's not needed on Google Cloud, but it's still if you want to do it on Google Cloud also you can do it. You need to deploy that on GKE, Google Kubernetes. Okay. So coming back to this over here. So that was just for your knowledge so that you are aware of. I will come back to the Vertex AI. So you can open any of the notebooks, whatever you have cloned, and you can run those experiments. Okay, so this is very basic experiment if you see, where they're installing certain packages, importing certain thing, giving the experiment name, testing run metrics, and so on, right? And this is the experiment they are running. So these kind of use cases you will you will find for your learning purpose, and they have whole lot of Google has their own learning tutorial as well if you want to go and check it out. Coming back to the use case over here, right? So for example, this is the wine pipeline use case where we are like trying to predict the wine quality, I think, or something. Okay. So in this, if you will look at, first you need to enable, you have to make sure that all the needed APIs, whatever we need, has been enabled. So we will run this. If any of the APIs are not enabled, it will give, or if you don't have the permission as a user, you need to request from your platform team or IT team to enable all the needed APIs. And once the APIs have been enabled, then you need to install certain packages. So once your all the required packages have been installed, then you need to configure certain variables like project ID, bucket name. So this is the bucket where all your artifacts and everything will be getting logged or stored, right? And project ID makes sure that you are in the right project, and also when the Vertex AI pipeline will be running, it will be like associating that to that particular project ID over here. So, and pipeline root is where you, whenever you run the pipeline under this directory, all your, for each of your pipeline, then your artifacts will be getting written. Okay. And then you import all the required packages. Then we create different components. So how components helps is, so if you look at this, right, this is similar to the Kubeflow structure. You can check it out later, but you can define your own dependencies, packages, base Docker image, and whatever dependencies you will define, all this configuration and settings can be outputted in a YAML file, so that if you want to go and look at like what is the configuration along with the code base, you can check out over here. So this is very simple use case, right? What we are like doing. So we will build this component has been built, and this if you look at it is just for loading the data and splitting that into train and test, and the output train and test data I'm writing back to the like I'm returning that as an output from this component, which will be leveraged in the train model component. And as a metric, I'm logging the data size of my train data size and test data size. Okay. So once this component, this cell I will execute, you can see this is how my YAML file will look like with all the settings, configurations, and everything. It will have the code, it will have the command to execute that code, and whatever packages and all I have installed, everything you can see from here in this YAML file. Okay, coming back to this, similarly, we have train model component where we have again the packages to install, whatever prerequisite we have base image, we have then like we are taking the input from the previous component. So we need train data over here, right? So that is coming as the input. We are training the model, random forest classifier. It's a basic model. And then we are dumping or we are saving that model at the cloud storage here, if you see. So still the model has not gone to the model registry at this stage. We have just trained the model. There's a different workflow which you can achieve. But just for understanding, like we have just trained the model and dumped that to the cloud storage. Then at next stage, we are evaluating the model for its performance. And if it meets those criteria, then we go ahead and deploy that model. And during the deployment, we will register that model in the model registry as well. Okay, so I think this is executed. So we evaluate the model, then we have the deployment. So this model is getting deployed on the online endpoint. So I've given the online endpoint name and all as well. And you can see how this is the logic to version the model. And for model deployment also, you need to choose the compute, right? What kind of machine you want to choose for deploying the model, how you want to split the traffic between different versions of the model. Those things can be handled logically with the code as well. Then once you have all the steps defined for your pipeline, you create the pipeline where all the required parameters, whatever you need to pass, you are passing from here, right? So in frame model, I have this dataset parameter. So this doesn't take the positional argument, your pipeline component. So you have to like make it keyword based arguments, which I'm changing right now. And once I have like all the things defined, so I have DSL condition if you see here, right? So it will only deploy the model if I will meet the threshold criteria. If my threshold criteria will not be met, then model deployment will not happen. So there are certain many other features and options to explore over here. In 1 hour session, I can't go in depth, but just for understanding, this will compile your end-to-end pipeline, whatever previously components we have defined. And ROC, the threshold metrics which we are considering over here is ROC 0.95 should be the value. If it goes below that, it will not deploy. If it is equal or above that, it will deploy. Then we will compile. So as we compile, it will create a pipeline JSON file, which can be deployed anywhere. So if you expand any of the components, you can see we have all the components defined over here. Be it load data, train and all. And here you can see all its input definitions and output definitions, everything. Okay, so all these things are being defined like this. And in pipeline info, you will get like what is the name of my pipeline. In root, you will get many other informations like what are the parameters and all which are going from here. So after the session, maybe I will share the code base and PPT with Siddhant and Harpreet, and they will share back with you or they can email you. So getting back to this, once you've compiled your pipeline and your JSON has been created, this JSON gets submitted to the AI platform for further execution. So let's submit the JSON. The pipeline will get triggered and it will give you the URL to track your pipeline run. If we come over here, you will see a DAG-like structure, something like this, where you can see all the different components, whatever we defined in the notebook, right? Load data, evaluate model, train model, and so on. Each of them are an individual step. If any of the steps will fail, it will not move to the next step. And for your understanding, since we implemented like if my threshold criteria is met after model evaluation, then only the model gets deployed. So this is how your DSL condition looks like. Okay. So if all the steps will execute completely luckily, then we will see the success. Like all the steps have been completed successfully. If any of the steps will fail, it will fail. Like it will stop the execution over there itself. So whenever the execution gets stopped, so there's a like argument over here in the pipeline itself. If you keep this argument enable caching true, it will resume from the failed step. If you will keep it false, then it will resume the pipeline run from the initial step. So this parameter is very important. So let's assume if it fails at very first step, for example, it can fail. I don't know, like I'm running this notebook after very long. If it fails, in that case, you have to resubmit it by making the code changes or whatever error you're getting by encountering that. Okay, so this is end-to-end Vertex AI platform. Before I move ahead, if you have any questions, please post in the chat. And whatever node is getting executed, right, you can click on that node and you can click on this button at the bottom to look at the logs of the execution of this node. Right? So you can see the logs are getting loaded. So you can track all the logs, like whether your code is getting executed properly or not, if any error has been encountered. You can enable monitoring on the logs as well. That's the like another step, but this is how you can achieve that. Now to automate each and all of these steps, right? So this is what I've done is just running from the notebook. So this pipeline JSON and the whole CI/CD pipeline, if you have to build, you need to like make use of different other services. Like we have Cloud Build on this, which is like your tool for make sure that whenever you deploy the code, a new Docker image gets built and gets triggered on the code push. So all those configurations and all you can configure from here. So you need to click on set up build triggers, give the configuration. You select the action, whether it's push new tag, push to a branch, or pull request, on which action you want to like trigger your code base pipeline run, and based on that, it will be triggered. Or you can like you can configure pub sub or webhook event as well. So all this configuration needs to be done, and then you will have the CI/CD in place for with the help of Cloud Build. And after that, if you have to deploy that in production, you can make use of Cloud Function. Like we don't have enough time, I will just stop over here, but just to give you the glimpse, you need to create a Cloud Function, write the Python script to read that JSON wherever you store it, and then call that final execution function by loading that JSON and submit the pipeline. So this will be running automatically whenever you trigger this function. Now this trigger, let's assume you have to set the cadence at a certain interval of time, right? So this function cannot trigger automatically. So you need Cloud Scheduler for that, so that you can schedule this function on a certain cadence, weekly, daily, monthly, however you want. So this is the Cloud Scheduler API which you need to enable, and based on that, it will be triggering that Cloud function automatically at the configured cadence, like whatever you've configured. And Cloud Build mainly for continuous like build, test, and deploy. Okay, so this is like high level understanding of Vertex AI. We were not able to go in very much in depth. And then there are different other services also based on where your data lies, like BigQuery or some other database and all you're using. Those connections and flow you can establish by your own. Few more things just to cover up for your understanding. On Vertex AI, we have generative AI capability as well. So if you are working on any of the Gen AI use cases and all, so Vertex AI Studio will be your go-to section where you can try Gemini, you can select whatever you want, you can open the playground, or you can play with the image models, speech models, whatever you want. If you click on open, it will take you to this is the language. So you can go with generate text, start a conversation, whatever kind of use case you want to work on. You can just select and play around with it. For example, this is the normal question I'm going to ask. Tell me about data couch, for example, right? If they will have the information, they will tell something. So data couch is something they are relating to the database or technology called data couch. Data couch string, let's say if I give example as, if they will have this information, they will be able to give the right details. If they don't have, the response comes like this. I don't have access to real-time information at all, right? So you can play around with the prompts. You can sort of like select your model. You can, if you want to fine tune the model or set the parameters and all, that also you can do. So I will stop over here. I will not like overgo the time, already 3 minutes over, but let me look at the question, what we have in the chat. Uh, yeah, from Jama I have to answer. How do we use our GPU on Docker? So Docker is just an image, right? It gets deployed on any of the compute. So compute can be GPU based compute or non-GPU based compute. So based on your use case, you can decide like what kind of compute you need for your deploying your Docker images. Next is any other question? Yes, Rama will share the code base with the team, and they will share with you. Data Couch conduct the courses, and they can help you with whatever required information you need, Vikash. So reach out to them. What skills or knowledge areas would you recommend for someone looking to specialize in? So you should be good with Python, SQL, the basics of ML, clear the concepts over there, and basics of DevOps as well. And then start with Vertex AI to handle end-to-end workflows. Ashraf, any prod grade use cases example, end-to-end big data streaming? Yes, there are many examples, Ashraf. Like this is very, very small. Like you can tell it's not even 5% complexity of what we can achieve on Vertex AI. It was a very simple use case just to get you started on Vertex AI. But production grade use cases will be very much complex and a lot of nuances you have to handle, starting from the code structuring to following certain design patterns, logging, monitoring, security aspects, end-to-end everything. Are there any specific courses that can help? For courses, there are many online resources available online, and even the Data Couch conducts training. So I think Mudit, they will be the right go-to person. Real world example where Vertex has significantly improved the efficiency of an ML pipeline. Just wanted to relate it with real world. There are many use cases, Tushar, because a lot of companies are on Google Cloud and they are leveraging Vertex AI for their ML use cases and generative AI use cases. And there has been significant improvement in terms of productivity, if I say, right? So like I have been working on Vertex AI since the time it has been launched. So it has matured and changed a lot. And how we were working before Vertex AI, manually integrating the components and taking care of the things. And now with this kind of platforms, and it's not just Vertex AI. On AWS also we have SageMaker. On Azure we have Azure AI Studio, AI services, right? Which we make use of, ML Studio. So it's all the cloud platforms have matured on these lines. What is MLOps scope of work, day-to-day operations? It's end-to-end, whatever I showed you in this architecture sort of. So there it is. Yeah, high level, whatever it comes, right? Be it like is it structuring the code, placing a proper folder structure in place, making sure the code is modularized, testing process in place, deployment is happening properly, like scaling, efficiency, security, governance, everything as an MLOps engineer you need to be aware of and be proficient with. Scripting, there's a multiple scripting language, Python, shell scripting also you need to do at times based on your use case or based on the requirement. So if I talk about the languages, then Bash scripting, Python, SQL, these are the basics which you should be very much proficient with to write good quality code. So I think I've answered almost all the questions. Any other questions? I will just take 1 or 2 more minutes. Over to you, Siddhant. If any questions will come to me, I will answer them.
Thank you so much, Shadab, for delivering such an insightful session. I hope it was a great learning experience for everyone there. So if anyone missed out on any part of the session and you want to see it again, you can go through the recording of the session that will be available on YouTube. And if you wish to explore further and want to reach out to us, you can contact us at hello@datacouch. So I have shared that email address in the chat also. And to stay updated on future informative sessions and content, we encourage you to subscribe to our social media channels and join our meetup groups. The links of this are shared in the chat. Thank you everyone for your participation, and we look forward to seeing you at our next event. Have a good night. Okay, bye bye.
Thanks, everyone. Bye.
Thank you, Shadab.